Hello friends, now we'll start the next topics, that is the addition theorem for two events. In these topics, we learn the addition theorem and the problems depending on these topics. At the same time, I had solved all the examples from the exercise 9.2. Now let us start. For any two events, A and B, of a sample space capital S, P of A union B is equals to P of A plus P of B minus P of A intersection B. This type of the formula that we have learned in the 9th standard also. At that time, we treat as the sets A and B. That is n of A union B is equals to n of A plus n of B minus n of A intersection B. Here we are considering in case of the probability, that is a P of A union B is equals to P of A plus P of B minus P of A intersection B. Now we'll start the exercise 9.2. The first problem, it's very simple exercise. First 6-faced die which is numbered 1 to 6 is thrown. Then 5-faced die is numbered 1 to 5 is thrown. What is the probability that sum of the numbers on the upper faces of the dice is divisible by 2 or 3? Now in the first case the die has 6 faces and in second case it has a 5 face. Die are thrown. Now 1 1, that sample space will be the 1 1 1 2 1 3 1 4 1 5. Now this. For the second, the only 5 faces are there. Therefore the second number will be noted as 1 1 1 2 1 3 1 4 1 5. The last number is 5. For the second, 2 1 2 2 2 3 2 4 2 5. For the third, 3 1 3 2 3 3 3 4 3 5. 4 1 4 2 4 3 4 4 4 5. 5 1 5 2 5 3 5 4 5 5. And the last is 6 1 6 2 6 3 6 4 6 5. Therefore, the total we will get, that is n of s is equals to 30. That is the total number of the sample space is 30. Let capital A be the event that the sum of the numbers on the upper face is divisible by 2. Therefore, the numbers are 1 1, 1 3, 1 5, 2 2, 2 4, 3 1, 3 3, 3 5, 4 2, 4 4, 5 1, 5 3, 5 5, 6 2, 6 4. These are the numbers. Again I will repeat, that is 1 1, 1 3, 1 5, 2 2, 2 4, 3 1, 3 3, 3 5, 4 2, 4 4, 5 1, 5 3, 5 5, 6 2, 6 4. Therefore n of a, number of the elements, n of a is equals to 15. Therefore P of a is equals to n of a upon n of s, that is 15 upon 30. Therefore second, the event that the sum of the numbers on the upper faces is divisible by 3. Therefore, the sample space is 1, 2, 1, 5, 2, 1, 2, 4, 3, 3, 4, 2, 4, 5, 5, 1, 5, 4, 6, 3. These are the sample points. Therefore, the n of B is equals to 10. Therefore, P of B is equals to n of B upon n of S, and the required probability is 10 upon 30. Now their intersection. What are the points? 1, 5, 2, 4, 3, 3, 4, 2, 5, 1. These are the common points. And therefore, n of A intersection B is equals to that is equals to 5. Therefore, P of A intersection B is equals to n of A intersection B upon n of S. That is 5 upon 30. Therefore, the required probability P of A union B is equals to P of A plus P of B minus P of A intersection B. Now substitute the values 15 upon 30 plus 10 upon 30 minus 5 upon 30, and that is equals to 20 upon 30. If we reduce it, then we will have the probability P of A union B is equals to 2 upon 3. Now we will see this. That is P of B is equals to n of B upon n of S, 10 upon 30. And their intersection is also 1, 5, 2, 4, 3, 3, 4, 2, 5, 1. N of A intersection B, that is equals to 5. I am summarizing all the problem, this problem. Therefore, P of A intersection B is equals to 5 upon 30. Therefore, required probability P of A union B is equals to P of A plus P of B minus P of A intersection B. 15 upon 30, 10 upon 30 minus 5 upon 30, which is 20 upon 30. That is P of A union B is equals to 2 upon 3. And this is the required probability. Now we'll start the second problem. A card is drawn from a pack of 52 cards. What is the probability that a card is either red or black? Now this is also a simple problem. There are 52 cards. One card is drawn from the 52 pack of 52 cards. That is a 52 C1, and that is equals to 52 ways. Therefore, n of S is equals to 52. Now A is equals to the event that the card is red or black. Now there are the 26 red and 26 black cards. One red card can be drawn from 26 red cards in 26 C1 ways. That is equals to 26 ways. Therefore, P of A is equals to n of A upon n of S. that is equals to 26 upon 52. Since A and B are mutually exclusive events, means they are the disjoint, they do not have the common element, and therefore P of A intersection B, that is equals to 0. Therefore the required probability P of A union B is equals to P of A plus P of B, and that is equals to 26 upon 52 plus 26 upon 52, and that is nothing but 1. Therefore P of A union B, that is equals to 1. Now second, card is either black or a face card. Now there are 26 black cards. Capital A, the event that the card is a black card, that is a one black card, can be drawn from 26 black cards in 26 C1 ways. Therefore N of A is equals to 26. Therefore P of A is equals to N of A upon N of S, that is a 26 upon 52. Therefore P of A is equals to 26 upon 52. Now next, B, the event that card drawn is a face card. Now one face card can be drawn from 12 face cards in 12C1 ways, that is a 12 factorial upon 12 minus 1 factorial into 1 factorial, and that is equals to, overall that is equals to 12. Therefore N of B is equals to 12. P of B is equals to N of B upon N of S, and that is equals to 12 upon 52. Since 6 cards are common between A and B, therefore A intersection B is equals to 6. Therefore P of A intersection B is equals to N of A intersection B upon N of S, that is equals to 6 upon 52. Therefore P of A intersection B is equals to 6 upon 52. Therefore the required probability P of A union B is equals to P of A plus P of B minus P of A intersection B, that is a 26 upon 52 plus 12 upon 52 minus 6 upon 52, and overall it is a 32 upon 52, which is P of A union B is equals to 8 upon 13. Now you can see again this, a card drawn from the pack of 52 cards. What is the probability that the card is either red or the black? One card is drawn from a pack of 52 cards, that is 52C1, that is equals to 52 ways. N of S is equals to 52. A, the event that the card drawn is a red card. One red card be drawn from the 26 red cards in 26 C1 ways. Therefore N of A is equals to 26. Now next is a P of A, therefore it's a probability P of A is equals to N of A upon N of S, 26 upon 52. Since A and B are mutually exclusive events, therefore they are disjoints. Therefore P of A intersection B is equals to 0. The required probability P of A union B is equals to P of A plus P of B, that is a 26 upon 52 plus 26 upon 52, that is equals to 52 upon 52, which is equals to 1. Therefore P of A union B is equals to 1. Second, a card is either black or face card. Now A is the event that one black card can be drawn from the 26 black cards in 26 C1 ways, that is equals to 26. N of A is equals to 26. P of A is equals to N of A upon N of S, that is a 26 upon 52. Be the event that the card drawn is a face card. One face card will be drawn from the 12 face card in 12 C1 ways. That is equals to 12. N of B is 12. Therefore, P of B is equals to N of B upon N of S. That's a 12 upon 52. Since 6 cards are common between A and B, therefore N of A union A intersection B, that is equals to 6. Therefore P of A intersection B is equals to N of A intersection B upon N of S, and that is equals to 6 upon 52. Therefore the required probability is equals to P of A union B is equals to P of A plus P of B minus P of A intersection B is equals to 26 upon 52 plus 12 upon 52 minus 6 upon 52, and hence the required probability is 32 upon 52, that is nothing but 8 upon 30. Now the problem number 3. A girl is preparing for national level entrance exam and state level entrance exam or professional courses. The chances of her cracking national level exam is 0.42 and that of state level exam is 0.54. The probability that C clears both the exam is 0.11. Find the probability that first C cracks at least one of the two exams. That we want to find out some of their probabilities. Let A is equals to the event that girls clears national level exam, entrance exam. B, the event that the girl clears state level entrance exam. It is given that the P of A is equals to 0.42, P of B is equals to 0.54 and their intersection is 0.11. Therefore, by using the addition theorem, that is C cracks at least one of the two exams. Therefore, P of A union B is equals to P of A plus P of B minus P of A intersection B, that is 0.42 plus 0.54 minus 0.11, and that is nothing but 0.85. Now next, C cracks only one of the two exams. Therefore, for that we will find out, that is it. By using this formula, P of A union B minus P of A intersection B. For this, you have to apply this type of the formula to crack one exam. That is it. P of A union B minus P of, that is equals to 0.74. Now next, C cracks none of the exam. That is, we want to find out P of A union B complement, and that is equals to 1 minus P of A union B, that is 1 minus 0.85, and their subtraction gives that is the P of A union B complement, that is equals to 0.15. See this again. A girl is preparing for the national level entrance exam and the state level entrance exam. For the professional courses, the chances of cracking the national level exam is 0.42 and the state level exam is 0.54. The probability that C cracks both the exam is 0.11. Find the probability that C cracks at least one of the two exams. A is equals to the event that the girl clears the national level entrance exam. B, the event that the girl clears the state level entrance exam. It's a given that P of A is equals to 0.42, P of B is equals to 0.54, P of A intersection B is equals to 0.11. C cracks at least one of the two exams, that is we want to find out P of A union B. That is equals to P of A plus P of B minus P of A intersection B. That is equals to 0.42 plus 0.54 minus 0.11, and that is nothing but 0.85. Second, C cracks only one of the two exams, that is we apply this formula which is given in the textbook, that is a P of A union B minus P of A intersection B. Therefore, 0.85 minus 0.11, that is equals to 0.74. C cracks none of the exam, that is a P of A union B complement is equals to 1 minus P of A union B, that is 1 minus 0.85. Therefore, P of A in union B complement is equals to 0.15. Now the next, problem number 4. A bag contains 75 tickets numbered from 1 to 75. One ticket is drawn at random. Find the probability that first, number on the ticket is perfect square or divisible by 4. One ticket can be drawn out of 75 ticket in 75 C1, that is equals to 75 S. Next, let capital A the event that the number on the ticket is a perfect square, that is 1, 4, 9, 16, 25, 36, 49, 64. Therefore, n of A is equals to 8. P of E is equals to n of A upon n of A, 8 upon 75. Next, B, the event that the number on the ticket is divisible by 4. Therefore, 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48, 52, 56, 60, 64, 68, 72. And therefore, n of B is equals to 18. Therefore, P of B is equals to n of B upon n of S. That is 18 upon 75. Therefore, now next they are common. The common points are, common numbers are 4, 16, 36 and 64. These are the squares and as well as divisible by 4 also. Therefore, n of A intersection B is equals to 4. Therefore, P of A intersection B is equals to n of A intersection B is equals to n of A S, 4 upon 75. Therefore, the required probability P of A union B is equals to P of A plus P of B minus P of A intersection B, that is 8 upon 75 plus 18 upon 75 minus 4 upon 75, which is 22 upon 75. B, number on the ticket is a prime number or greater than 40, given that the number on the ticket is a prime number. The prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73. N of C is equals to 21, therefore P of C is equals to N of C upon N of S, and that is equals to 21 upon 75. This is very simple. Now next, D, be the event that the number on the ticket is greater than 40. Now these are the greater than 40, 41, 42, 43, up to the 75, which are N of D is equals to 35. Therefore, P of D is equals to N of D upon N of S, that is equals to 35 upon 75. Now they are common points, common numbers, that is 41, 43, 47, 52, 59, 61, 67, 71, 73. Therefore, N of C intersection D is equals to 9. Therefore, P of C intersection D is equals to N of C intersection D upon N of S, and that is equals to 9 upon 75. Therefore, the required probability, that is P of C union D is equals to P of B plus P of C plus P of D minus P of C intersection D. That is 21 upon 75 plus 35 upon 75 minus 9 upon 75. That is 47 upon 75. Therefore, P of C union D is equals to 47 upon 75. You can note down now. This very simple problem. One ticket is drawn. 75 ways. The first is perfect square. These are the perfect square. N of A is 8. P of A is N of A upon N of A is 8 upon 75. B, the event that the number on the ticket is divisible by 4. These are the numbers which are divisible by 4. Therefore, P of B is equals to 18. N of B is equals to 18. P of B is equals to N of B upon N of A is 18 upon 75. Now their intersection 4, 16, 36, 64. N of A intersection B is equals to 4. Their probabilities 4 upon 75. Therefore, the required probability, that is 22 upon 75. Now next, the number on the ticket is a prime number or greater than 40. These are the prime numbers. N of C is 21. 21 upon 75, this is P of C. D, the event that the number is greater than 40. These are the 35 numbers, therefore N of D is 35. P of D is N of D upon N of D is 35 upon 75. They are common numbers. There are the 9 numbers. Therefore, P of C intersection D is equals to N of C intersection D upon N of S. 9 upon 75. Therefore, the required probability is 21 upon 75, 35 upon 75 minus 9 upon 75, and hence the required probability is 47 upon 75. Now we'll start the problem number 5. The probability that a student will pass in French is 0.64, will pass in sociology is 0.45, and will pass in both is 0.40. What is the probability that the student will pass in at least one of the two subjects. Now this is the problem. Now we'll start its solution. It's very simple problem. Students' probability pass in French is P of F is equals to 0.64. Next is probability pass in sociology. P of S is equals to 0.45. Probability in both, that is a P of F intersection S is equals to 0.40. Therefore, by using the addition formula, P of F union S is equals to P of F plus P of S minus P of F intersection S. Now we'll substitute their values. 0.64 plus 0.45 minus 0.40. Then you will have 1.09 minus 0.40. That is equals to 0.69. This is the probability of F union S. Now the next problem, problem number 6. Before that, we'll again see the total solution of this problem. The probability that a student will pass in French is a 0.64 and will pass in sociology is a 0.45 and will pass in both is a 0.40. What is the probability that the student will pass in at least one of the two subjects? Now we'll see the answer. That is, a student's probability in which is a pass in French is P of F is equals to 0.64. Probability of passing in sociology is the P of S is equals to 0.45. Probability to pass in the both, that is the P of F intersection S is equals to 0.40. Therefore, by using the addition formula, P of F union S is equals to P of F plus P of S minus P of F intersection S. Now substitute the values. 0.64 plus 0.45 minus 0.40, and that is equals to 1.09 minus 0.40, and that is equals to P of F union S is equals to 0.69. Now we'll start the next problem, that is a problem number 6. Now see this problem number 6. Two fair dice are thrown. Find the probability that number on the upper face of the first die is a 3 or sum of the numbers on their upper faces is 6. Now, this is a problem. Now see this solution. Before that, again I will repeat the problem. That is, a two fair dice are thrown. Find the probability that the number on the upper face of the first die is a 3 or the sum of the numbers on their upper faces is a 6. Now, when two fair dice are thrown, the sample space capital S is 1 1 1 2 1 3 1 4 1 5 1 6. Next is 2 1 2 2 2 3 2 4 2 5 2 6. 3 1 3 2 3 3 3 4 3 5 3 6. 4 1 4 2 4 3 4 4 4 5 4 6. Next is 5 1 5 2 5 3 5 4 5 5 5 6. 6-1, 6-2, 6-3, 6-4, 6-5, 6-7, 6-6. Sorry. Now n of s is equals to 36. Let n of s is equals to 36. Now the first event is that the number on the upper face of the first die is 3. Therefore, a is equals to 3-1, 3-2, 3-3, 3-4, 3-5, 3-6. This is the important. Therefore, n of a is equals to 6. P of a is equals to n of a upon n of s. That is a 6 upon 36. That is, you will get 6 upon 36. Next is B, the event that the sum of the numbers on the upper faces is 6. Therefore, B is equals to, in curly bracket, 1, 5, 2, 4, 3, 3, 4, 2, 5, 1. That is, sum of their numbers is 6. Therefore, their numbers is addition 5 plus 1, 4 plus 2. Therefore, n of B is equals to 5. Therefore, P of B is equals to n of B upon n of S, 5 upon 36. And that's why, again, their intersection. The intersection is clear that the sum is 3 plus 3 is 6. And the first number is also 3. Therefore, n of A intersection B is equals to 1. And then we'll find out its probability. That is the P of A intersection B is equals to n of A intersection B upon n of S. That is 1 upon 36. And that's why P of A intersection B is equals to 1 upon 36. The required probability P of A union B is equals to P of A plus P of B minus P of A intersection B. This is the formula. Therefore, 6 upon 36 plus 6. Second, 5 upon 36 minus 1 upon 36, and solve this. That is 10 upon 36. This is the probability, which is nothing but 5 upon 18. P of A union B is equals to 5 upon 18. Now we'll see again the same problem. That is, the two fair dice are thrown. Find the probability that the number on the upper face of the first die is 3, or the sum of the numbers on their upper faces is 6. When two fair dice are thrown, the sample space, capital S is, this is the given, the sample space. Okay. All these are regularly, we write always now. I am not repeating again this. Therefore, n of S is equals to 36. A, the event that the number on the upper face of the first die is 3. Therefore, we take the first die 3 number, and the total number is 6. Therefore, we have P of A is equals to n of A upon n of S, that is a 6 upon 36. Now, next is the B, the event that the sum of the number on the upper face is 6, 1, 5, 2, 4, 3, 3, 4, 2, 5, 1. Therefore, n of B is equals to 5. P of B is equals to n of B upon n of S, that is a 5 upon 36. And their intersection, that is A intersection B is equals to 3, 3. N of A intersection B is equals to 1. Therefore, P of A intersection B, that is n of A intersection B upon n of S, is equals to 1 upon 36. And that's why the probability P of A intersection B is equals to 1 upon 36. The required probability, that is the P of A union B, is equals to P of A plus P of B minus P of A intersection B, that is a 6 upon 36 plus 5 upon 36 minus 1 upon 36. And that's why you will get 10 upon 36, that is equals to 5 upon 18. Again, P of A union B is equals to 5 upon 18. Now see the problem number 7. For the two events A and B of a sample space capital S, if P of A is equals to 3 upon 8, P of B is 1 upon 2, find P of A union B is, and that is, now I will repeat this problem again. What is that? P of A union B is equals to 5 upon 8, not find. This is a find. Find the value of the following. Now see this, which are the values that we required. First is P of A intersection B. Next is probability of A complement intersection B complement. Probability of A complement union B complement. Now we'll see one by one. The first we have, that is a P of A is equals to 3 by 8. P of B is equals to 1 upon 2. P of A union B is equals to 5 by 8. The first is P of A union B is equals to P of A plus P of B minus P of A intersection B. Substitute the values. Then you will get, that is a 5 by 8, 3 by 8, 1 upon 2 minus P of A intersection B. That is P of A intersection B is equals to 3 by 8 plus 1 upon 2 minus 5 upon 8. That is a minus, which is after calculation. That is a minus 2 by 8 plus 1 upon 2. After simplification, you will get minus 1 upon 4 plus 1 upon 2. And overall, you will get 1 upon 4. This is the P of A intersection B is equals to 1 upon 4. Second, B, P of A complement intersection B complement, that is nothing but by using the De Morgan's law. That is a P of A union B bracket complete complement. This is the important formula by using the, that is a 1 minus P of A union B. And substitute only the values, 5 by 8, 1 minus 5 by 8. Then this is the formula, this you have to remember, 1 minus 5 by 8, and that is equals to 3 by 8. P of A complement intersection B complement is equals to 3 by 8. Next is P of A complement union B complement is equals to probability of A union B bracket complete complement, that is equals to 1 minus probability of A intersection B, and that is equals to 1 minus 1 upon 4, and that is equals to 3 by 4. Therefore, probability of A complement union B complement is equals to 3 by 4. Now we'll see the same problem. Problem number 7. For the two events A and B, the sample space S, if the P of A is equals to 3 by 8, P of B is equals to 1 upon 2, probability of A union B is equals to 5 by 8, find the values of the following. Probability of A intersection B, probability of A complement intersection B complement, probability of A complement union B complement, that is we have given this. Probability of A is equals to 3 by 8, probability of B is equals to 1 upon 2, probability of A union B is equals to 5 by 8. Now first we want to find out probability of A intersection B. Now by using the addition formula, that is the probability of A union B is equals to P of A plus P of B minus P of A intersection B, and that is equals to 5 by 8 is equals to 3 by 8 plus 1 upon 2 minus probability of A intersection B. After substituting and calculations, you will get probability of A intersection B is equals to 3 by 8 plus 1 upon 2 minus 5 upon 2. That is nothing but minus 2 by 8 plus 1 upon 2 minus 1 upon 4 plus 1 upon 2, and that's we will get, that is equals to 1 upon 2 minus 1 upon 4, that is equals to 1 by 4. Therefore, probability of A intersection B is equals to 1 upon 4. Now the next is Product of A complement intersection B complement. This is nothing but product of A union B and their complement by using the De Morgan's law. And product of A union B complement is nothing but 1 minus product of A union B. That is 1 minus 5 by 8 and that is equals to 3 by 8. Therefore, product of A complement intersection B complement is equals to 3 by 8. Now, the next is, that is the product of A complement union B complement is equals to product of A intersection B complement, which is nothing but 1 minus product of A intersection B, that is equals to 1 minus 1 by 4 and that is equals to 3 by 4. Now again, we'll see the next problem. Problem number 8. For the two events A and B of a sample space capital S, if P of A union B is equals to 5 by 6, product of A intersection B is equals to 1 upon 3 and product of B complement is equals to 1 upon 3, then find P of A. We have P of A union B is equals to 5 by 6, product of A intersection B is equals to 1 upon 3, product of B complement is equals to 1 upon 3, product of B is equals to 1 minus product of B complement, that is equals to 2 upon 3, that is 1 minus 1 upon 3, that is nothing but the 2 by 3. Therefore, P of B is equals to 2 by 3. Product of A union B is equals to P of A plus P of B minus P of A intersection B. Now, substitute the values. That is 5 by 6 is equals to P of A plus 2 by 3 minus 1 upon 3 and P of A is equals to 5 by 6 minus 2 upon 3 plus 1 upon 3. Therefore, P of A is equals to 5 by 6 minus 1 upon 3. Therefore, P of A is equals to 5 minus 2 upon 6. That is equals to P of A is equals to 3 upon 6. That is equals to 1 upon 2. Therefore, P of A is 1 upon 2. Now the same thing, that is, we will see problem number 8. For the two events A and B of a sample space capital S, P of A union B is equals to 5 by 6, P of A intersection B is equals to 1 upon 3 and the P of B complement is equals to 1 upon 3, then find P of A. That is, we have that is a product of A union B is equals to 5 by 6, product of A intersection B is equals to 1 upon 3, product of B complement is equals to 1 upon 3, product of B is equals to 1 minus product of B complement, and that is equals to 1 minus 1 upon 3, which is 2 upon 3. Therefore, P of B is equals to 2 upon 3. Next is product of A union B is equals to P of A plus P of B minus product of A intersection B. Substitute their values. That is 5 by 6 is equals to P of A plus 2 by 3 minus 1 upon 3. And after calculation, this is very simple thing that you can calculate. That is a P of A is equals to 3 by 6, that is equals to 1 upon 2. Therefore, P of A is equals to 1 upon 2. Now we'll start the problem number 9. A bag contains 5 red, 4 blue and an unknown number m of green balls. If the probability of getting both the balls green when the two balls are selected at random is 1 upon 7, find the value of m. Now in this case, the bag contains 5, 4 blue, 5 red and unknown. That number is treated as m. M plus 9 balls. If the two balls are drawn from the bag. Therefore, n of s is equals to m plus 9c2 g is equals to the event that both balls are green. There are m green balls. Two green balls can be drawn in MC2 ways. Therefore, n of g is equals to MC2. It is given that P of g is equals to 1 upon 7. N of g is equals to, that is, P of g is equals to 1 upon 7. N of g upon n of s is equals to 1 upon 7. MC2 upon m plus 9C2, that is equals to 1 upon 7. And now we'll calculate, that is a 7 MC2 is equals to m plus 9 C2. Now their calculations, that is a 7 into m factorial upon m minus 2 factorial into 2 factorial. M plus 9 factorial upon m plus 2 minus m plus 9 minus 2 factorial into 2 factorial. Now we perform their calculations. Now this m factorial can be extended up to the m minus 2. Then m minus 2 will cancel. And for this m plus 9 factorial. And this is a m plus 9 minus 2 means what? M plus 7. Therefore, this can be again extended to up to the m plus 7 factorial. Now we'll see the calculations. This is the extended. In this case, m minus 2 will get cancelled. To the right hand side, we can write m plus 9, m plus 8, m plus 7 factorial, which is m plus 7. Now these two get cancelled. 2 also get cancelled. That is 7 into m minus 1. That is equals to m plus 9 into m plus 8. (7m square minus 7m is equals to m square plus 9m plus 8m plus 72. 6m square minus 7m minus 17m minus 72. That is equals to 0. 6m square minus 24m minus 72. And again we will lowest this by dividing the 6. M square minus 4m minus 12 is equals to 0. And the factors are m minus 6, m plus 2. Therefore m is equals to 6 or m is equals to minus 2. But m is not minus number. So that is a positive. Therefore m is equals to 6. M cannot be negative. Therefore m is equals to 6. Now see this again. A bag contains the 5 red, 4 blue and unknown number of m green balls. If the probability of getting the both balls green when the two balls are selected at random is 1 upon 7, then find the value of m. The bag contains 4 plus 5 plus unknown m, that is m plus 9 balls. If the two balls are drawn from the bag, therefore n of s is equals to m plus 9c2. G, the event that the both balls are green, there are the m green balls. That is, the two green balls can be drawn in MC2 ways. Therefore, n of g is equals to MC2. It is a given that the P of g is equals to 1 upon 7. N of g upon n of s is equals to 1 upon 7. And that's why MC2 upon m plus 9C2 is equals to 1 upon 7. Make their cross multiplication. Then you will get 7 times MC2 is equals to m plus 9C2. And that's why you will get 7 into m factorial upon m minus 2 factorial into 2 factorial. And that is equals to m plus 9 factorial upon m plus 9 minus 2 factorial into 2 factorial. Now after the calculation, this m factorial can be again written as m into m minus 1 into m minus 2 factorial. M minus 2, m minus 2 get cancelled. To the right hand side, m plus 9, m plus 8, m plus 7, this m plus 7 get cancelled, 2 also get cancelled. And after calculation, this is very simple calculation, you can also perform. I have repeated. Quadratic equation. The value of m is equals to 6 or m is equals to minus 2. The value of m is not negative, therefore we take that m is equals to 6. Problem number 10. From a group of 4 men, 4 women and 3 children, 4 persons are selected at random. Find the probability that first, no child is selected. All problems are very simple. That is the total number of the persons are 4 plus 4 plus 3, that is equals to 11. 4 persons can be selected from these 11 persons in 11C2 ways. N of s is equals to 11C2, and that is equals to 11 factorial upon 11 minus 4 factorial into 4 factorial. This is a simple calculation. That is a 11 into 10 into 9 into 8 into 7 factorial. 7 into 4 into 3 into 2 into 1, 7 factorial get cancelled. And you will get n of s is equals to 11 into 10 into 3. Let capital A the event that no child is selected. Since no child is to be selected, 4 persons have to be chosen out of the remaining, that is 8%. Therefore, this can be done from the remaining 8%. Number of children are 3. Therefore, the event is 8C4. This is the event 8C4 ways. And find out their calculations. That is n of a is equals to 8C4. 8 factorial upon 8 minus 4 factorial into 4 factorial. And its calculations is written as 8 into 7 into 6 into 5 into 4 factorial. Now this is 4 factorial into 4 factorial. Now again it can be written as 4 get cancelled, 8 into 7 into 6 into 5, 4 into 3 into 2 into 1. That is equals to 7 into 2 into 5. N of a is equals to 7 into 2 into 5. The required probability, that is P of a is equals to N of a upon N of s. 7 into 2 into 5, 11 into 10 into 3, and that is equals to 7 upon 33. P of a is equals to 7 upon 33. Exactly 2 men are selected. That is a 4 men. There are the 4 men, that is a 4C2. And now the remaining are 4 plus 3. That is a 7. And from this 7% we can again select the 2. That is 7C2. That is 7 factor selected. Therefore, n of b is equals to 4C2, 7C2, and 4 factorial upon 2 factorial into 2 factorial, 7 factorial upon 5 factorial into 2 factorial, and their calculations, that is a 4 into 3 into 2, 2 into 2 factorial, 7, 6, 5. This is the calculation. That is equals to 3 into 6 into 7. The required probability, that is the P of B, is equals to N of P upon N of S. That is a 2 into 3 into 7 into 3. 11 into 10 into 3. That is a 21 upon 55. Therefore, P of B is equals to 21 upon 55. That is the answer given in the textbook is different one. Now this is my answer. Now the same problem. From a group of the 4 men, 4 women and the 3 children, 4 persons are selected at random. Find the probability that no child is selected. Now the total number of the persons are 4 plus 4 plus 3, that is equals to 11. 4 persons can be selected from these 11 persons, that is the 11C4 ways. Therefore, n of s is equals to 11C4, 11 factorial upon 11 minus 4 factorial into 4 factorial. After their calculations, n of s is equals to 11 into 10 into 3. Let capital A the event that the no child is selected. Since no child is to be selected, 4 persons have to be chosen out of remaining 8 persons, which can be done in 8C4 ways. Therefore, n of A is equals to 8C4, 8 factorial upon 8 minus 4 bracket complete factorial into 4 factorial, and their calculations, that's n of A is equals to 7 into 2 into 5. The required probability P of A is equals to n of A upon n of S, that is 7 into 2 into 5, 11 into 10 into 3, therefore P of A is equals to 7 upon 33. Exactly 2 men are selected, that is 4 men. There are the 4 men where we require the exactly 2 men, therefore it is a 4C2. Now the remaining are 4 women and the 3 children. Total are 7. Now from this 7 we can select the 2, because total we require the 4, and that's why that is a 7C2. These 2 and these 2, that is a total is 4. Therefore, n of B is equals to 4C2 into 7C2, and that is equals to 4 factorial upon 4 minus 2 factorial means 2 factorial into 2 factorial. 7 factorial upon 5 factorial into 2 factorial, and after calculations, that is, you will get 3 into 6 into 7. Therefore, P of B is equals to n of B upon n of S, and that is equals to 2 into 3 into 7 into 3 upon 11 into 10 into 3. Therefore, P of B is equals to 21 upon 55. Now we'll see the next problem. Answer in the textbook is a different one, but my answer is this. You can check. Now the problem number 11. A number is drawn at random from the numbers 1 to 50. Find the probability that is divisible by 2 or 3 or 10. A number can be drawn from the numbers 1 to 50 in 50 C1, that is equals to 50. One number is drawn. What about the event which is divisible by 2, 3 or the 10? Therefore, first is the event that the number is divisible by 2, the number is divisible by 3, and C is equals to the event that the number is divisible by 10. That is, a capital A is equals to, these are the numbers which are divisible by 2. N of A is equals to 25. It's clear that. Therefore, P of A is equals to N of A upon N of S. That is equals to 25 upon 50. B is equals to the numbers which are divisible by 3. Therefore, N of B is equals to 16. Therefore, P of B is equals to N of B upon N of S. That is 16 upon 15. 50. See which are divisible by 10. These are the numbers. Therefore, N of C is equals to 5. Therefore, P of C is equals to N of C upon N of S, 5 upon 50. Also, N of A intersection B is equals to 6, 12, 18, 24. Their intersection. N of A intersection B is equals to 8. P of A intersection B is equals to N of A intersection B upon N of S, 8 upon 50. B intersection C is equals to 30 only. Therefore, N of A B intersection C is equals to 1. Probability of B intersection C is equals to N of B intersection C upon N of S, that is 1 upon 50. C intersection A is equals to, these are the 10, 20, 30, 40, 50. Therefore, N of C intersection A is equals to 5, and their probability of C intersection A is equals to N of C intersection A upon N of S, that is equals to 5 upon 50. A intersection B intersection T is equals to 30. Therefore, N of A intersection B intersection C is equals to 1. Therefore, probability of A intersection B intersection C is equals to N of A intersection B intersection C upon N of S, that is 1 upon 50. The required probability, that is the probability of A union B union C, is equals to P of A plus P of B plus P of C minus probability of A intersection B minus probability of B intersection C minus probability of C intersection A plus probability of A intersection B intersection C. Substitute the value of 25 upon 50 plus 16 upon 50, 5 upon 50 minus 8 upon 50 minus 1 upon 50, 5 upon 50 plus 1 upon 50, and their calculations. And write these calculations. That's 25 plus 16 plus 5 minus 8 minus 1 minus 5 plus 1. And overall, you will get upon 50, 33 upon 50. That is the probability of A union B union C is equals to 33 upon 50. In this way, we have completed the exercise 9.2. Now we'll see in the next video. Till then, goodbye.